puzzled look on your faces. Things smile might challenge you a little bit. Somebody always gets it. Maybe it's still now. Don't be the first class ever to fail. You got anything? This might be the first one on the academic challenge questions. Be ready for it. You got it, Cooper?
Oh, no.
What? All right, anybody want to take a stab at it? Josh?
Is it 43?
Is it 43? All right, you got to explain your reasoning, and it has to work for all of them. So how'd you come up with 43?
I guess.
You guessed. Okay. I will neither confirm nor deny it. Okay, Luke.
47.
It's 47. Okay, what is your reasoning?
The digits add up for like the increments. So like 3 plus 7 is 10.
Oh. Does that work? Goes up 4, 8, 7, 5, which is clearly a pattern. So not. All right, 1 plus 3 is 4. 1 plus 7 is 8. 2 plus 5 is 7. 3 plus 2 is 5. 3 plus 7 is 10. 47 is the answer. So, all right, the streak lives. The streak lives. Good job, Luke. Woo! All right, so you never know. I mean, sequences come in all kind of varieties. Like you said, some people like just you'll just look over that. Some people just see things a little bit different. Okay, because it depends on what you're looking for. Because you've been conditioned, for arithmetic sequences like a common pattern, and you're like, well, there's no pattern. 4, 8, 7, 5. There's obviously no pattern. But if you look a little bit closer, Luke found it. All right, on your homework. Let's see, 58. Take a look at your terms there, but it should be negative 4, 7, negative 26, 73, and negative 224. 82 should be negative 56. 86 should be negative 3. What's 87? Negative 118. Negative 118. All right, 23, 25, 27, and 29. All right, 29. What did you get, Ryan?
For 29, a sub n is equal to negative 2/5 n minus 1/5.
Okay, you got that. Now, who has what was in the back of the book? Okay, who verified that? Because it wasn't exactly the same. You're fine. You're right. That's okay. What was it? Nobody? What do you got?
Was it like negative 2 plus 1 over 5n?
Negative, it was, hold on. Negative 2n plus 1. It was like that. Yep. All right, here's my question. The way they have it written, if you wrote it, I guess my question is, are those the top and the bottom one equivalent? Okay, are they equivalent? The way I have them written. Mackenzie, what do you think? Gut feeling.
Well, Ryan should have said that.
So you go with Ryan.
Yes.
So you have no opinion.
I don't know.
They're not equivalent. Okay, they're not equivalent. This is the answer in the back of the book. This is correct. Theoretically, this would be incorrect. Okay, well, why? How come they aren't equivalent? All right, what's the difference, Ryan, since you're going with your answer?
The negative would distribute to the 1 as well.
Right, this negative, the way you have it written, or the way it is written there. Okay, when it is out in front, if you apply it to the numerator, you have to treat it like that. You have to treat it like that. It's negative the quantity 2n plus 1. So for it to be equivalent, it would be negative 2n minus 1 over 5. That would be the case. Okay? Just want to make sure that's a subtle difference, but I want to make sure you understand it. Now, if I'm converting this, probably 9 out of 10 of you got that point right there. Some of you did some decimals. But, all right, how do I go from here to here? They both have a denominator of 5. It would be negative 2n minus 1 over 5. And then, all right, well, that's not what they had in the back. If you want to match it, or you got a multiple choice, you factor out the negative, and that makes that a plus 1. And then you can just put that out in front. But make sure you understand that difference. Okay, this is different here. Those are not equivalent. That negative does apply to the entire numerator. And so negative 2/5 n minus 1/5, fine. Absolutely fine. Got it? All right, what do you got for 40? Okay, or it's right there. You better get 4n plus 3. All right, 40. And then how about 41? Josh, what do you got for 41?
I think I have negative 2n minus 4.
Aaron, you agree?
Negative 2n plus 4.
You said minus 4.
Minus 4. That's not what I got.
What did you get?
I got negative 2n plus 22.
Plus 22.
That's what I got too.
Oh, we got a confirmation. What did you do wrong, Martin?
I have no idea.
Yeah, I don't either, because you don't show any stinking work. So I'm not giving you full credit. Because I can't figure out what you're doing. Okay, so put something down so I know what's going on. All right, it should be negative 2n plus 22. Okay, for that one. All right, here's a little revision. I didn't get all the way through the notes yesterday, so it's like a little cumulative effect here. I don't want to try and rush through everything on 11.3. So we're going to finish up the notes today. You're going to have an assignment. You'll have a good chunk of class to get it done or get it close to done. We'll hit 11.3 tomorrow. We'll review Friday. Since it's only on 3 sections, I'm not too concerned about getting you a quiz on Monday. We'll do a quiz on Monday. All right, so bumping everything back a day for that. All right, we're finishing up those notes. So there's just a few there on the back. So how many did you have last night? 10? So 4 off, right? What did I say, 14? 45, 38? All right, the sum, all right, if you got your book handy, turn to page 1011. This is good for you academic challenge people and all you math geeks out there. 1011.
I don't think I have that.
Yeah, because you were trading. Carl Friedrich Gauss. He is one of the in all of history, one of the top mathematicians in all of history. Okay, read through that little blurb if you would on that left-hand side. See, those of you who don't go through your book, you miss all these great stories. I'm not being sarcastic, Madison. There's a lot of great stories. Okay, take the history of math when you get, those of you math people, if you get into math, take the history of math class when you get to college. It's a good time. All right, Carl Friedrich Gauss. Okay, he discovered this formula for the sum when he was 8. Okay, when he was 8. That's not too bad. Basically, they had to add up the numbers from 1 to 100. Okay, and he figured out a little bit of a shortcut for that. And so take a look at an arithmetic sequence, and I'll go over this equation here in a second, but I'm just going to give you any generic arithmetic sequence. And let me do this. And so let me just start at 3, 5, 7, 9, 11, 13. Just 6 terms to do easy. All right. What did the first and last term add up to? 3 plus, what's first and last term? Add up to what? 16. 5 and 11 adds up to 16. 7 and 9 adds up to 16. How many 16s do I got? 3. So 3 times 16, 48. Okay. So does that always work? Yeah, essentially that's always going to work. Okay, that idea. So let me start it with a negative. Let's say negative 9, and let's go up by 4. Negative 5, negative 1, 3, 7, 11, 15, 19. That's easier to do with an even number of terms, but it still works with an odd number of terms. All right. Well, what's negative 9 and 19? 10, right? So that adds up to 10. What's negative 5 and 15? 10. Negative 1 and 11? 10. 3 and 7 is 10. How many pairs of 10s do I got? 4 of them. 4 times 10 is 40. Add them all up. So this is where we come up with this equation. Now, the book gives it to you this way, which is equivalent to, I like to do it this way. You add the first and the last term, cut it in half. That's how many pairs you're going to have. So you take n divided by 2, and then times whatever the sum of the first and the last term is. Okay, that's going to work for any arithmetic sequence. Okay, you can do it this way. You can add them up and then divide by 2, and then that's a little bit what Carl did here. He's a little bit more advanced than I am. Okay, but either way, that works for that. Now, how does that work if you got an odd number? Okay, it still works fine. Okay, but you just got an extra one. So if I go negative 9, negative 5, negative 1, 3, 7, okay, that gives me what? Negative 2, negative 2, and then you got one left over. Okay, that's where you'll have, basically you'll have the extra half you just added in there. Okay, so you take n divided by 2. So if it's an odd number, 5 divided by 2 is 2.5. Well, you'll have 2 pairs, and then you have that 1/2 will be whatever that sum is left over. Okay, for that one. So it ends up working out either way. All right, let's take a look at the case here. All right, find the sum of this arithmetic sequence of numbers. So negative 13 plus negative 10 plus negative 7 plus all the way up to 80. Now, the sum is the number of terms divided by 2, first term plus the last term. All right, unfortunately, we're missing a little bit here. What are we missing? Missing a number of terms. We got to figure it out. We know the first term, we know the last term. Now, you could list them all out if you're, really persistent person and enjoy that. But we can figure that out using this right here. A sub n equals a sub 1 plus n minus 1 times d. This just gets used over and over and over in different situations. We're going to use that to find n. The last term is 80. That is going to be your a sub n. We know d in this case is what? 3? So 80 equals the first term, which is negative 13, plus n minus 1 times 3. All right, solve that. You make a careless mistake and you get a decimal or a fraction, you got to know something's wrong because the number of terms can't be a decimal or a fraction. It's got to be a whole number. And so what do we get here? 80 equals negative 13 plus 3n minus 3. 80 equals 3n minus 16. Add 16, 96 equals 3n. n equals 32. All right, so that lets me know in that pattern, if that pattern continues, it starts at negative 13, it goes to 80, I'm gonna have 32 terms. Now, since I got 32 terms, I can figure out the answer. S sub n equals 32 divided by 2, negative 13 plus 80, 16 times 67. And multiply that together. Hold a loop and let me know what you get.
1,042.
1,042. We agree?
I got 72.
72, did I hear you wrong? 72? If Lane said it, it's gotta be right.
Yeah, he's got the precise decimals too.
1,072, double check that. Okay. 1,000. Let's hit something. All right, so 1,072. All right, do this, you do the second one. Here it is. You're like, where's it at? There it is. 1, 3, 5, continue that pattern all the way up to 215. Now, if you get on the ACT and you forget your little formula, you just have to type them all in your calculator. It wastes about 7 valuable minutes. Or you can be like Carl Friedrich Gauss, the 8-year-old, figure it out. Gauss is supposedly the last person to know everything there was about math at the time. Like, there's so many little pockets that, like, there's no one person that knows everything that's going on in the math world. Allegedly, he was the last one. Now you got fractal geometry. Vector analysis. We gotta check with Lane. What's your Lane? Alright, you guess it. We're good. Yeah. Look at when the answer key. Alright, what did you get for N? Tony, what did you get for N?
106.
106, ooh. Double check that. Double check that. So A sub n equals plus n minus 1 times g. Find a mistake yet?
Would it be 109?
You're getting closer. You're getting closer. You're in the ballpark. Why don't we just tell you it's 108? 108. So 215 equals 1 plus 2n minus 2. I get 215 equals 2n minus 1. When you add the 1, I get 216. I bet you subtracted 1. 2n, n equals 108 for that one. All right, so now I can use my formula. S sub n equals n divided by 2 times the, that's the first and the last term. Basically means we have 54 pairs. Each pair adds up to the first plus the last, which is 216. And then what is it? Lane?
11,664.
Okay, 11,664. All right, so that should be the final answer there. So that's when you know the first and you know the last term. All right, let's take a look at that second set there. I don't know the last term. I know the first term, I know the pattern, and I know the number of terms. So we got to find the last term. Same idea. Use a sub n equals a sub 1 plus n minus 1 times d. We don't know the last term. That's what we're going to find. But we know the n value for the last term is 50. That'll go in for where's n minus 1. D is 4. And so I get a sub n equals 1 plus 50 minus 1 times 4. 1 plus 196. Looks like I get 197. Okay. All right, so that's my last term. S sub n, the sum of n terms. What's n divided by 2? 50 divided by 2. First term is 1 plus, what do we got there? 197. Okay. In the end, Emily, what'd you get?
4,950.
4,950. Lane, do you agree?
I do.
All right. We got to be right. All right, 4,950. All right, you do this next one on your own. And it is right here. Start at negative 12, negative 9, negative 6, 30 terms. Good. All right, I got 75 for the 30th term. That should be a sub 30. So then I get 30 divided by 2. First term is negative 12 plus the last term is 75. 15 times 63. Nathan, more. What you get?
945.
945. All right, we agree? All right. So that is just finding the sum of an arithmetic sequence. All right. Page 1003, 1014, just kind of continue on those.